And the crazy part is, at peak, Netflix is ingesting trillions of events per day just for their observability pipeline. Trillions! That's more than the number of stars in the galaxy.
Trillions? Seriously? Okay, that's a lot. So we're talking about observability at a scale that most of us can barely even fathom. But why is that level of observability even necessary? What happens if you don't have it?
Well, imagine you're running a service like Uber. Millions of rides happening simultaneously, payments being processed, drivers being matched. If something goes wrong, a surge pricing glitch, a payment failure, a driver unable to connect, it's not just one user affected, it's a cascade. Without proper observability, you're basically flying blind. You're reacting to customer complaints instead of proactively fixing issues.
Right, so you're firefighting instead of preventing the fire in the first place. And that costs money, both in terms of lost revenue and in engineering hours spent scrambling. But what's the alternative? Just throwing more logging at the problem? Because I've seen that turn into a complete unmanageable mess.
Exactly. More logs aren't necessarily better. It's about structured observability. We're talking about the trifecta: metrics, logs, and traces, all working together, and that's where tools like Prometheus, Grafana, and distributed tracing come into play. Think of it like this. Metrics tell you something is wrong, logs tell you why, and traces tell you where the problem originated in your distributed system.
Okay, that's a good high-level overview. Let's break that down a bit. Let's start with Prometheus. For someone who's never used it, how would you describe it?
Imagine Prometheus as a super efficient data collector, constantly scraping metrics from your applications and infrastructure. It's like a diligent little robot that's always asking, how's your CPU usage? How many requests are you handling? What's your error rate? The crazy part? It stores all that data in a time series database, which is specifically designed for this kind of monitoring data.
So it's not just storing the data, it's storing it with a timestamp. That makes sense for tracking trends over time. But how do you actually get those metrics into Prometheus? Do you have to rewrite all your code?
Not at all. You instrument your code. Think of it like adding little sensors to your application that expose metrics in a standardized format that Prometheus understands. Most languages have libraries that make this super easy. For example, you can use a Prometheus client library in Python to track the number of HTTP requests your API is handling. Then Prometheus just scrapes those endpoints periodically. It's like a doctor taking your temperature regularly.
Okay, that sounds manageable. But what about existing applications that weren't built with Prometheus in mind? Is it still possible to integrate them?
Absolutely. That's where exporters come in. Think of them as translators. They take metrics from systems that don't natively speak Prometheus and translate them into a format that Prometheus can understand. There are exporters for everything: databases, message queues, web servers, you name it. Cloudflare uses a ton of exporters to monitor their global network. They have custom exporters for everything from DNS resolution times to the health of their edge servers.
That's really smart. So Prometheus is collecting all this data. Now what? I imagine that looking at raw time series data isn't exactly user-friendly.
Exactly. That's where Grafana comes in. Grafana is your visualization powerhouse. It takes the data from Prometheus and turns it into beautiful, informative dashboards. Think of it as the cockpit of your spaceship, giving you a clear view of everything that's happening in your system.
Cockpit of your spaceship. I like that analogy. So you can create graphs, charts, and all sorts of visualizations. But how do you know what to visualize? Where do you even start?
That's the art of dashboard design. You want to focus on key performance indicators, or KPIs. These are the metrics that are most critical to the health and performance of your system. For example, if you're running an e-commerce site, you might want to track things like conversion rates, average order value, and website latency. Amazon is famous for its operational dashboards. They have dashboards for everything from order fulfillment rates to the performance of their AWS services. They even have dashboards tracking the health of their internal developer tools.
So it's not just about pretty graphs, it's about visualizing the right data, and those KPIs are going to be different for every application. But what about complex distributed systems, where requests are hopping between multiple services? How do you track a single request as it flows through the entire system?
That's where distributed tracing comes in. Think of it like following a detective through a city as they investigate a crime. Each service in your system adds a span to the trace, recording how long it took to process the request and any relevant metadata. The crazy part? You can then visualize the entire trace, seeing exactly where the request spent its time and where any bottlenecks occurred.
Okay, so it's like a detailed audit trail for every request. But how do you actually implement distributed tracing? It sounds incredibly complex.
It can be, but there are tools that make it much easier. Open telemetry is becoming the standard for instrumenting your code for tracing. It provides a vendor-neutral API that you can use to collect traces and then export them to various tracing backends, like Jaeger or Zipkin. Google uses distributed tracing extensively in their internal systems. They can track requests as they flow through thousands of microservices, helping them identify performance bottlenecks and debug complex issues.
So OpenTelemetry is the standard way to collect the tracing data, and Jaeger or Zipkin are the tools that store and visualize it. But doesn't adding all this tracing code add a lot of overhead to your application?
That's a valid concern. And it's true, there is some overhead. But the benefits of distributed tracing often outweigh the cost, especially in complex systems. The key is to use sampling. Instead of tracing every single request, you only trace a small percentage of them. This reduces the overhead while still giving you enough data to identify problems. Stripe, for example, uses adaptive sampling to automatically increase the sampling rate when they detect anomalies.
Adaptive sampling, that's clever. So you're only increasing the tracing when you suspect there's a problem. But wait, doesn't that mean you might miss some subtle issues that don't trigger the adaptive sampling?
That's the trade-off. You have to balance the cost of tracing with the risk of missing issues. It's not a perfect solution, but it's often the best compromise. Here's where it gets interesting. Most engineers focus on the technical implementation of observability, configuring Prometheus, building dashboards, instrumenting their code, but they often neglect the human side of observability.
The human side? What do you mean?
I mean, who is actually looking at these dashboards? Who's responsible for alerting? Who's analyzing the traces to identify the root cause of problems? Observability isn't just about collecting data, it's about empowering your engineers to understand and improve your system. It's about building a culture of ownership and accountability.
So it's about creating a feedback loop. The data informs the engineers, and the engineers use that information to improve the system, which then generates more data. But how do you actually foster that culture of ownership? It sounds great in theory, but it can be hard to implement in practice.
It starts by making observability data easily accessible to everyone. Don't hide your dashboards behind walls. Make them visible to the entire team. Encourage engineers to explore the data and ask questions. Also, invest in training your engineers on how to use the observability tools and how to interpret the data. Think of it like teaching them how to read a map.
Okay, that makes sense. Transparency and training are key. But what about alerts? How do you avoid alert fatigue, where engineers become desensitized to alerts because they're constantly getting bombarded with false positives?
Alert fatigue is a real problem. The key is to focus on meaningful alerts. Don't alert on every single metric. Focus on the ones that are most likely to indicate a real problem. And make sure your alerts are actionable. The alert should tell you exactly what's wrong and what they need to do to fix it. Think of it like a well-written error message.
So it's not just about alerting, it's about alerting intelligently, and it's about empowering engineers to actually do something about the alert. Okay, so let's say I'm an engineer who's been listening to this and thinking, okay, I need to improve our observability. What are 3 specific, actionable things I can do this week?
First, start small. Don't try to boil the ocean. Pick one critical service and focus on instrumenting it with Prometheus. Add some basic metrics like CPU usage, memory usage, and request latency. Think of it like planting a seed. Second, create a simple Grafana dashboard to visualize those metrics. Focus on the KPIs that are most important to the health of that service. Think of it like building a birdhouse. And third, implement basic distributed tracing for a single API endpoint. Use OpenTelemetry to collect the traces and export them to Jaeger or Zipkin. Think of it like learning to ride a bike. Once you've mastered these 3 things, you can start expanding your observability coverage to other services.
Okay, start small, build a dashboard, and implement basic tracing. I like that. It's concrete and achievable. So what's the one thing you want our listeners to take away from this episode?
Observability isn't just a technical problem, it's a cultural imperative. It's about empowering your engineers to understand and improve your system. It's about building a culture of ownership and accountability. Think of it as building a house, not just a collection of bricks. You need a strong foundation and a clear vision to create something truly valuable.